Hi guys, I apologize for not being in class today, but my son is still sick, so I'm home with him. I'm very much hoping to be back tomorrow, but I have created a video of today's lesson. Today's lesson is pretty short just because we are on an open house schedule. Just a few reminders. Make sure that you get your objective sheet for Chapter R, Part 1 done. It is due tomorrow. I have your tests done and we'll pass them back to you tomorrow as well. Okay, so here we go. Make sure either you pick up the paper copy or the electronic copy. And if I ever go too fast or you need to see something again, feel free to fast or rewind or pause. Okay, so we are starting Chapter R, Part 2, and Day 1 is over rational expressions. You've hopefully dealt with these before, but it's just the quotient of two polynomials. So an example would be something like 1 over x, or 3x squared plus 4x minus 5 all over x plus 2. Another concept for today is domain of the rational expression. Domain, you've probably remembered as what x's can I use. It's the set of real numbers for which the expression is defined. Remember that the denominator cannot equal 0, so that will help us determine what is not in our domain. So here we go. First one says to go ahead, simplify, and find the domain. Okay? So let's go ahead and simplify. We're going to use all of our factoring skills. As I've said, factoring is going to come up pretty much every chapter. Therefore, an 8x plus 12 over 6x plus 9. First of all, do not just say, well, 8x over 6x is 4 over 3. And then 12 over 9 is 4 over 3. 8x and 12 are connected through addition. Addition and subtraction cannot be broken like that. You can only do reducing if they're connected by multiplication. Therefore, in this case, I would take out a 4. Oops, that was sloppy. Take out a 4, and I'm left with 2x plus 3 from the numerator. And I can do the exact same thing from the bottom. Out of 6x plus 9, I could take out a 3, leaving me once again with 2x plus 3. I can now reduce, because 4 is connected to that 2x by 3 plus 3 by multiplication, and 3 is connected by multiplication, I can reduce out that 2x plus 3, leaving me with our final answer of 4/3. Now, when it comes to domain, do not look to your reduced rational expression. Instead, go back to the original. So I'm going to write that. For domain, use original. Therefore, I'm going to look at our original problem, 8x plus 12 over 6x plus 9. And where my domain is restricted is in that denominator. I have to make sure that I am not dividing by 0. Therefore, I'm going to set 6x plus 9 and set that it cannot be equal to 0. And then just solve that. I get 6x cannot equal -9, and x cannot equal -9/6, or better yet, x cannot equal -3/2. Now, how we want you writing this is in set notation. So I'm going to say domain. You're going to say the set of x such that x cannot equal -3/2. So what that's saying is that in the set of real numbers, anything will work but -3/2. Therefore, I can plug in any other x value and it will work into that rational expression. It will be defined. Whereas if I plug in -3/2, I'll be dividing by 0, and as we know from last chapter, that is not allowed. Okay. Depending on time, you guys could pause this and try it on your own, but I know we're going on 25 or 30 minute period. So here we go. 3x and an x. I'm thinking 3x times 5 will make that 15. And if I put my 1 there, I'll have -15 plus 1 gets me my -14. And then the bottom, I notice that I have 25 minus x squared. And I need to get an x minus 5, not a 5 minus x. Therefore, I'm going to take out, I'm going to factor out a negative 1 from that 25 minus x squared, and I will get x squared minus 25. Then I will go ahead and factor the rest of the denominator. I'll have 3x plus 1 times x minus 5 still in the numerator over negative 1 times x minus 5 and then x plus 5. Taking out now that common factor of x minus 5, I can do that because it's connected by multiplication. I'll be left with 3x plus 1 over negative 1 times the quantity of x plus 5. I'm fine with that. Or if you write it as 3x plus 1 over negative x minus 5. Either one's good. Once again, I'm going to go back to the original for the domain. Sorry, I've got all these scratches here, but that's domain I'm going to work with. And I'm going to take 25 minus x squared, and I'm going to say that it cannot equal 0. You can either add your x squared over and take the square root, which we haven't talked about yet, or we can do what we have done. 5 minus x, 5 plus x. We haven't really talked about the zero product property, but you hopefully remember that from Algebra 1. I'm going to set each of my factors now equal to 0. Actually, not equal to 0. And I end up with that 5 cannot equal x, so x cannot equal 5. And then 5 cannot equal negative x, which should be that negative 5 is not equal to x. Therefore, my domain will be all x, all real numbers x, such that x cannot equal negative 5 or 5. Okay, now we're asked to find the product or the quotient. Looking at number 3, 4r squared over 9r cubed times 21r over 16r squared. Many, many, many different good ways of doing this one. Some people like to reduce each rational expression first, then multiply. Some people like to multiply numerator with numerator, denominator with denominator, then reduce. Some people like to take one numerator and reduce it with either of the denominators. It really doesn't matter. I'm going to go ahead and just reduce each rational expression. Therefore, I'll have 4 over 9. R squared over r cubed will leave us with r in the denominator. And I'll have 21 over 16r. And while I'm at it, here's where I'm going to reduce any numerator with any denominator. So like 4 and 16, that's going to turn to a 1. 16 will turn to a 4. 21 and 9 are each divisible by 3, therefore I'm going to change that into a 7 and a 3. You could have also gone ahead and just said, well, 4 times 21 and 9 times 16 and reduce that way. I just avoid the larger numbers. And now I have 7 over 12r squared, which cannot be reduced anymore. Okay, number 4, x squared minus 16 over 5x to the 8th. I'm going to keep that as is. You could do a lot more in one step, but I'm just going to go ahead and write times. I'm going to multiply by the reciprocal, 20x cubed over 6x squared plus 19x minus 20. Some of you may have learned it as keep, change, flip, or whatever, but we don't want division. Instead, we multiply by that reciprocal. Now that I see that, I'm going to go ahead and I'm going to factor. X squared minus 16 is x minus 4, x plus 4, over 5x to the 8th, times 20x cubed, and 6x squared plus 19x minus 20. Take a little bit of time to think about that one. My guess is most of you guys started with 2x and a 3x. Here's where you can look for some hints. I'm probably trying to reduce out either the x minus 4 or the x plus 4. Well, keeping that in mind, that's a 1x. 1x times 6x gets us that 6x squared. So I'm actually going to start with a 6x and an x. And my guess is it should be an x plus or a minus 4. So I'm going to leave that at 4. 6 times our 4 makes 24. Well, I need to complete that 20, so I'm going to put a 5 here. And if I do 24 minus 5, I'm at my 19. Therefore, it was 6x minus 5 times x plus 4. Now I'm going to reduce out my x plus 6, or excuse me, x plus 4. I'm going to reduce my 20 and 5 to a 4 and a 1. You could do that later. It's up to you. I'm going to take x to the 3rd and an x to the 8th and realize that makes an x to the 5th in the bottom. And then I think we are good. I'll have 4 times x minus 4 all over x to the 5th times 6x minus 5. I'd probably leave it like that, but you could also go ahead and make it 4x minus 16 over 6x to the 6th minus 5x to the 5th. And then finally, this fun one. You probably don't want to do this, but I'm going to just rewrite my first two rational expressions. And then I'm going to multiply by that reciprocal of 3x squared plus x over x squared minus x minus 20. I always just get nervous of, thinking I'm going to flip it, but then forgetting to. That's all. Okay, so now 2x and an x. Let's see, with a 6 or with a 12, I can't do a 2 and a 6 because there'd be a GCF, so I'm going to do a 3 and a 4. Have to put my 3 with the 2 and my 4 elsewhere. So that would be 8 and 3. Well, I could do 8 minus 3. And then the bottom, a 3x and a 3x. I'll do a 4 and a 2, giving me 12 minus 6. So if I do a negative 12 and a positive 6, I get to my negative 6x. Now, times, we have a difference of squares. 3x minus 4, 3x plus 4. Once again, if you get stuck on that 6x squared minus 7x minus 3, look for things in the numerator, either 2x minus 3, x plus 4, 3x minus 4, 3x plus 4. I'm going to try 2x and a 3x. To make 3, I cannot put 3 with my 3x, so I'm going to put it here and 1. And I will now have 2 and 9. Therefore, I have a positive 2 and a negative 9. I get to my negative 7. 3x squared plus x, I'm going to take out our x. We'll be left with 3x plus 1. And then finally, x squared minus x minus 20. X minus 5 times x plus 4. Now it's time to reduce. I see a 3x minus 4 on top and bottom. I see an x plus 4 and an x plus 4. I see a 3x plus 1, a 3x plus 1. And then I see a 2x minus 3 and a 2x minus 3. And that could be it, leaving me with x times 3x plus 4 over 3x plus 2 times x minus 5. So x times 3x plus 4 all over the quantity of 3x plus 2 times the quantity of x minus 5. And I'm not going to bother multiplying that out. Last thing, at the very bottom, just remember when you're working on tonight's problems that x minus 4 cubed, all cubed, is not equivalent to x cubed minus 4 cubed. Just think about from last chapter that x cubed minus 4 cubed factors into x minus 4 times x squared plus 4x plus 16, which is very different than the quantity of x minus 4 cubed. Okay, like I said, I hope to return tomorrow. If you have any questions, feel free to email. I'll be in 7:30, hopefully Friday morning, if you have some questions. Homework is day 1. And I plan on starting out class tomorrow by giving back our tests. Have a great half day and see you tomorrow.